of Module 3, Fibonacci Formula and Linear Recurrence Relations. C.1, Golden Ratio. We, work on the Fibonacci numbers in the previous video. So we look at a, algorithmic way to solve it. We compare two different methods. One is much better than the other, the dynamic programming, right? So now we get to the second direction. Solve it mathematically. Try to derive a math formula. The reason is very simple. If we can get a formula, it will be much faster than you write a program. You solve it in a programming way, usually not as fast as the formula way. But derive the formula, it is pretty hard. So you will see in this part C, we will use 4 videos to solve Fibonacci number problem mathematically. So you can expect we need to do a lot of math here. All right, so let's start. First, look at this picture. This picture use some simple way to show you the Fibonacci number properties. Some of the Fibonacci number properties. Look at this one first. So we draw squares, but we arrange the squares with the sides the same as the Fibonacci numbers in order, in sequence. All right, so we skip the 0 one. Nothing there. And we know F2 equals 1, right? So you can see we start 1, 1, then 2. That's F3, F4, arranged in this way. So you can see if we follow this pattern, we can grow a rectangle. We can grow a rectangle. Okay? Then when you get a rectangle somewhere, then you draw a curve. The curve just, use one vertex of a square as the center, the side as the radius. You draw a quarter circle. That's arc. Quarter circle arc. Right? So you can see, from the inner, you get out, so really nice, beautiful curve. Right? Then you make arrangement in this special way. All right, so now then you can see if you look at the ratio, here, longer segment, shorter segment, the ratio of these two segments gives a very special number. So that number is the golden ratio. So this picture actually gives us the relationship between the golden ratio and Fibonacci numbers. From the geometry. Here, we look at that from the geometry. Next, we will look at the relationship from the algebra. In algebra, can we connect these two different types of numbers? But we need to do a lot of work to get that. First, let us calculate golden ratio first. So this is a very famous special number. The golden ratio, the definition is very simple. Yeah. In this picture, you see the definition here. Yeah. But here I draw the diagram. Yeah. You start with a line segment. Then you break it into two pieces, two segments. Yeah. Longer and shorter. But there is a relationship between these two segments. The relationship is in the ratio. The ratio, so here, A is the longer segment over B, shorter segment, should be equal to the whole segment, A plus B, over the longer segment, A. If we use this relationship, can we solve the ratio? Yeah, here we simplify the fraction a little bit. Yeah, A over A, that's 1, so we make it a little simpler. The question is, can we solve this equation to get a ratio A over B? Yeah, so that's our goal. Yeah. Here you can see, if you look at the original equation, there are two variables, A and B variables, but we only have one equation. Yeah. We know in order to solve an equation with two variables, if we do not have two equations, it's very hard to find the exact numbers for those two variables. So that's our experience. But here we do not need to find exact numbers of those two variables. We only need to find the ratio of two variables. That's different. That's different. Yeah. All right. Because we only care about the ratio, can we use a new variable x to represent the ratio? Yeah. Yeah. That's the one we are targeting, so we use a new variable to represent that ratio. In that way, then B over A just a reciprocal of the variable x. In this way, you can see we changed the original equation to a new equation with one variable, x. And we know we can find the value of x with certain formula, right? Yeah. So let us simplify the equation a little bit. Yeah. Next, let's solve this equation. Yeah. We know it is a quadratic equation, and we have quadratic formula to find the solution. Okay. Yeah. The formula is this. Yeah. I hope you can still remember this formula. Yeah. Here, let us plug in the coefficients A, B, C to get a final answer. But the final answer, here you can see plus minus. There are two possible solutions. One, use the plus version, 1 plus root 5 over 2. Another 1 minus root 5 over 2. Yeah. All right. But if we want to go back to the geometry, background. Yeah. Remember in our, first slide, geometry background, then the ratio can only be positive number, right? Yeah. In that case, geometry background, we can only pick the positive solution, 1 plus root 5, whole thing over 2. Yeah. So that's approximately 1.618, the golden ratio number. All right. Here, we drop the negative solution. There is a negative solution for this equation, and we drop that. The reason is for that geometry, meaning when we use the geometry interpretation, we drop it. Yeah. But later, we may not use geometry interpretation. Later, we just use the algebra. Algebra techniques. In that situation, we need to bring back that negative solution because we don't consider geometry. If you don't consider the geometry, then the negative solution is also useful. Yeah, so we need to bring it back later when we do it in algebra way, not geometry way. Geometry way, algebra way, different. All right, so let us continue. All right, next, because this number is so special, so we like to use a special symbol to represent it. Here, usually people use the Greek letter phi. Greek letter phi to represent golden ratio. Now, just like using Greek letter pi to represent the circular rate, right? Yeah. All right. All right. Magic formula for the Fibonacci number. Here, let me give you the formula first. Then we try to prove, verify, and understand this formula. This formula is not very easy to see it. Why we have this formula? So that you will see the power of math. Why we can get this kind of special formula? Because we use math tools. Yeah. All right, this is the formula. F of n equals 1 over root 5 multiply parenthesis phi to the nth minus negative 1 to the nth over phi to the nth. So special, right? Golden ratio is used. So the formula, you see the connection. But why is that? Yeah, we couldn't understand. Why is that? Yeah. All right? Yeah. Because we know Fibonacci numbers are all integers. And the golden ratio is not an integer. It is an irrational number. It is not even a rational number. It is an irrational number. I hope you know the definition of irrational number. Okay? Rational number and irrational number. So these two. So real number can be divided into two categories. Yeah. In this way, rational number and an irrational. Rational, irrational number. Okay. All right. The rational number, very simple. We can represent as ratio of two integers. Ratio of two integers, m over n. Yeah, definitely n not equal to 0. Yeah. All right. Yeah. All ratio. Irrational number you cannot represent as any integer ratio. Yeah. And this is irrational. Phi. Yeah. The question is, how can you use irrational numbers through some magic formula to get an integer value? Right? Yeah. Yes, you can. Yeah. Yes, you can. But to understand it, we need to do a lot of things to understand it. Yeah. All right. So next, we will try to understand in two different ways. Yeah. Still, mathematically, we use two different ways to understand it. Yeah. All right. So this is our first video of part C. So you get some basic information to start our investigation in Fibonacci numbers. All right, so let me stop here.